Today's lesson is going to be about Hess's Law, which basically states that the overall enthalpy change of a reaction is equal to the sum of the enthalpy changes of the component reactions. So basically, if you know the enthalpy change associated with some reactions and you can rearrange them in a fashion that gets you to your overall goal equation, you can make your manipulations and then add up the energy changes for each, and then that will give you the total enthalpy change for the reaction. So our goal equation in this case is to find out the enthalpy change for the combination of carbon with hydrogen to make butane, and we're given these component reactions. So what we want to look for when we do this is we want to first look at where each substance appears in our goal equation. So for example, first thing I'm looking at here is that butane appears in the reactant side in the equation we're given, and it appears in the product side of our goal equation. So what we're going to want to do here is we're going to want to flip this equation so that butane appears on the product side, so that way we end up at this. Looking at the next two equations, you can see that in our goal equation we have 4 carbons reacting. In the equation we're given we only have 1. So what we'd want to do here is multiply this whole equation by 4, and when we do that we have to multiply the enthalpy change by 4 as well. And similarly, the hydrogen, there's only 1 hydrogen appearing in the equation we're given, and in our goal equation we have 5 hydrogen molecules. So in order to get an appropriate delta H, we have to multiply this whole equation by 5 as well as the enthalpy. So having done that, we are flipping the first equation and then multiplying the other equations by the appropriate coefficients, we can get to our goal equation. What's going to cancel out at this point so that we end up there? On this side we have 6.5 oxygens, and if you notice, oxygen does not appear in our goal equation. On this side we have 6.5 oxygens as well, so these are going to cancel out. In addition, 4 carbon dioxides on each side, those are going to cancel out as well. Also, our 5 water molecules on each side will disappear, and that will leave us with our goal equation of 4 carbons combining with 5 hydrogens to make 1 butane. And having made our manipulations to the equations and making these similar manipulations to our enthalpy changes, when we add up these enthalpy changes, we can determine that the total enthalpy change for the reaction is equal to -125 kilojoules.